I am Iqbal Bajwa, chemistry teacher and resource person for O and A levels. Students, today our topic of discussion for O level is experimental chemistry. So you all are familiar with the lab and lab practicals. So today we have to study about the different apparatuses used in the lab. Measurements in chemistry. Chemistry is an experimental science. When doing experiments, we make observations and take measurements. There are four basic physical quantities measured in chemistry experiments: volume, temperature, time, and mass. To measure these quantities accurately, we use measuring instruments. For example, we use a thermometer to measure temperature and balance to measure mass. Measurements in chemistry experiments. Now, this is a question that how we measure different quantities in chemistry. So, first of all, volume of liquids, definitely we have to measure, which deals with the volume. Volume of gases, temperature, time, mass. Volume of liquids, first of all, the SI unit for volume is the cubic meter, m cube. At this is a large, as this is a large unit. We usually measure volumes of the liquids in cubic centimeter. Larger volumes are occasionally measured in cubic decimeters. 1 decimeter cube is equal to 1000 centimeter cube. Now, how we measure the volumes? First of all, beaker and conical flask. If we talk about the beaker, a beaker and a conical flask both hold an approximate volume. So they deal with the approximate volume. Conical flasks, as I said earlier, conical flasks hold an approximate volume and it is used mostly in titration experiments. Measuring cylinder. A measuring cylinder gives a more accurate volume than a beaker, but is only accurate to the nearest centimeter cube. Now this is the shape, the look you can see the measuring cylinder is. Then burette. A burette is a long scale from 0 centimeter cube to 50 centimeter cube. The level of a liquid is read off the scale. The liquid is run out from the burette by turning on the tap. The level of the liquid in the burette is measured before and after running out of the liquid. The difference in reading gives the volume of liquid released. A burette can deliver into a container any volume of liquid up to 50 centimeter cube. Now this is near to accuracy, accurate to 0.1 centimeter cube. Now have a look on the burette. Now this is the burette. You can see that on the one side there is a tap which is used to control to pour liquid from the burette into the other apparatus, into the conical, normally into the conical flask. And the right hand side shows the upper side starting from the 0. So in this way we can measure volume by the help of burette. Pipette. Precise volumes of liquids can be measured with the bulb pipette. Such a pipette measures out a very accurate set of volume, such as exactly 20, 25, 50 centimeter cube. A pipette cannot measure an odd volume such as 26 centimeter cube. To use a pipette, the liquid is drawn up the pipette to a mark using pipette filler. The liquid is then delivered into a container for use. So this is the diagram showing, this is the slide showing the typical pipette. So we can measure an approximate volume, not approximate but exact volume of the liquid. with the help of pipette. Then volume of gases. Volume of gas produced in a chemical reaction is measured with a gas syringe. The gas can be collected in the syringe, but this is not safe. If the conical flask containing the reaction mixture is being heated with a Bunsen burner, the gas syringe measures up to 100 centimeter cube of gas on a graduated cylinder. So this is a typical gas syringe. You can see the graduations, the marking, the points, they are mentioned on the gas syringe, with the help of which you can take the volume of gases. The next is the temperature. The temperature of a chemical is measured with the thermometer. The usual laboratory thermometer is a mercury in glass or alcohol in glass type, in which the liquid expands with the rising temperature, resulting in an increase in the length of the mercury or alcohol thread. The SI unit for temperature is Kelvin. The symbol is K, capital K. However, most thermometers have a temperature scale with a non-SI unit, the degree Celsius, with the symbol of capital C. Now this is the typical slide. This is the slide showing the typical thermometer, which is giving reading to measure out temperature. Time. The SI unit for time is second, capital S. Other units are the hour, the small h, and the minutes we use. Time is measured with a clock or digital stopwatch. For O-level chemistry experiments, you only need to measure time to nearest second, as it is not necessary to be more accurate. So this is the stopwatch with the help of which we can measure out time. Mass. The mass of a substance is the measure of the amount of matter contained in it. The SI unit for mass is kilogram. In chemistry, smaller masses are measured in grams or milligrams. In the chemistry laboratory, the mass of a chemical is usually measured with an electronic top pen balance or a beam balance, such as the triple beam balance. Some electronic beam balances can be read to 0.001 gram, which shows its accuracy, while a triple beam balance can be read to only 0.2 gram. In the chemical industry, large quantities of the substances are used. Large masses can be measured in ton. So 110 ton is equal to 1000 kilograms. Now these are the two diagrams showing the electronic balance and beam balance. So thank you so much for having with me with the Iqbal Bajwa. Inshallah, in the next videos we have more topics to discuss. Thank you so much.